Do we live in a matrix? The argument that our universe could be a simulation is based on the possibility that an advanced civilization, or one in the future, might be able to simulate the universe and create lifelike entities that would not be able to distinguish that they are not in a real universe. There are a number of unexplained phenomena in nature that some people have suggested could be evidence that we are living in a simulated universe. Some of the proposed bugs in the simulation include quantum mechanics phenomena like wave-particle duality, superposition, and entanglement do not have a clear explanation in classical physics. The fine-tuning of physical constants and laws of nature seem to be, well, finely tuned for the existence of life. The universe's apparent low entropy at the beginning is a perplexing question in physics, known as the arrow of time problem. The existence of dark matter and dark energy, which are mysterious forms of matter and energy, make up the majority of the universe's mass and energy, yet they have not been directly observed. While these unexplained phenomena could be seen as potential bugs in a simulated universe, it's important to keep in mind that these are just natural phenomena with alternative, much simpler explanations. For example, the fine-tuning of the physical constants can be explained by the theory of the multiverse. If the universe can accommodate a large enough number of big bangs, most of them uninhabitable to life, then it is natural that some of them would appear to be fine-tuned to accommodate life. There are also much simpler explanations about the nature of dark energy and matter, such as that dark energy is the relic energy from the Big Bang, and that dark matter could possibly consist of supersymmetric particles. It has also been suggested that the universe might be able to reset its entropy according to the model of the cyclic universe. There are also much simpler explanations about the wave-particle duality, in particular that what we perceive as particles are just waves. Regarding currently unsolved physics problems as bugs can hardly be considered a convincing argument to support the idea that we are just simulation beings. Simulating the entire observable universe, including all of its complex data and interactions, would require an enormous amount of computing power. One way to estimate the energy requirements of such a machine would be to consider the energy consumption of current supercomputers and scale it up to the level needed to simulate 10 to the power of 90 atoms. Current supercomputers consume on the order of several megawatts of power, which is a very large amount of energy. For example, the Summit supercomputer at Oak Ridge National Laboratory in Tennessee, which is currently one of the most powerful supercomputers in the world, has a peak power consumption of around 13 megawatts. If we assume that the energy requirements scale linearly with the computational power of the machine, we can estimate that such a machine would require on the order of trillions of megawatts or terawatts of power. The Sun's power output, being 38.46 million times greater, suggests that this computation would require an amount of energy incomprehensibly large by human standards, but still within reach of stellar-scale processes like those in the Sun. Additionally, there are many other types of particles and forms of energy present in the universe, such as photons, neutrinos, and dark matter, that would also need to be taken into account in a simulation. These particles interact with one another and with the atoms, so simulating these interactions would require additional computational power. It is entirely unclear what would be the benefit of putting hard work to create such a complex computer simulation. The laws of physics and the fundamental constants of nature determine the maximum amount of energy that can be harnessed and the maximum amount of computation that can be performed in a given period of time. These limits constrain the performance of physical systems, including computers, and ultimately determine what is and is not possible. For example, the laws of thermodynamics set limits on the maximum efficiency of energy conversion, and the laws of quantum mechanics set limits on the precision of certain measurements. Additionally, the speed of light is a fundamental limit that sets a maximum speed at which information and energy can be transmitted. These limits would also apply to advanced alien civilizations, despite they might have different levels of technology and understanding of nature. It's also worth noting that our current understanding of the laws of nature is incomplete, and there may be other fundamental limits that we are currently not aware of. As our understanding of the universe deepens, we may discover new constraints that will further limit the performance of physical systems and computers. So, while an advanced alien civilization might have access to technologies and resources that we can't currently imagine, they would still be subject to the same fundamental laws of nature that constrain the performance of physical systems and computers. And simulating the universe would still be a practically impossible task. Most importantly, in a simulated universe, the simulated entities, such as mathematicians, would still be able to work out the same mathematical ideas as in the real universe. The mathematical laws that govern the universe, such as those of physics and chemistry, are considered to be independent of the underlying physical reality and would still hold true in a simulated universe. If we therefore live in a simulation, the real universe should also be 13.8 billion years old, according to what we know. However, 13.8 billion years ago, it is impossible that alien life could possibly exist in order to start running the simulation, since just after the Big Bang, the universe was totally inhabitable. The question that arises is if aliens could possibly run the simulation fast enough so that, for example, for them they would only elapse 13.8 minutes, while for us they would elapse 13.8 billion years. The time scale between physical phenomena that we observe is something real and dependent on the intrinsic properties of matter, and not something that can be arbitrarily compressed or expanded according to the hypothetical tastes of an alien civilization who runs a simulator. We hope that this video will be a food for thought for those bending their minds around this interesting thought experiment. Don't hesitate to like and share this video and let us know in the comments section your ideas and comments.